Okay, first up, with your graphing calculator, you can do some pretty cool things with parametrics. All right, let's just play with one right now. Everybody put your calculator into parametric mode. There's func mode, stands for function. There's pol mode, which what do you think that stands for? Polar, and now you're going into para. Go into para mode on your calculator. I'll pause while I do that. Okay, so we're on this page, and I'd like you to type in these two for your x and y equations. Notice it says t max equals 10, and the t step equals 0.1. Just a quick hint, those are not on all on one page. Okay, to start with, your x and your y, those are going to be on the first page. The other two are going to be somewhere else. Let's see if you can figure out where they are. Okay, so I got my graphing calculator to graph this. This is nothing super special, but as you can imagine, if you play with this, you can get some pretty amazing things to graph. All right, now I'm going to give you just a minute of playtime. Everybody use the same window, and now I'd like you to, I would encourage you to consider using sine, cosine, that kind of thing, and see if you can figure out something kind of cool. All right. So, Mr. G, looks like you already have found something. Yeah. Give me something, and then nobody else can copy yours. You have a patent on this one. Right. Wait a second. So you're on the y equals screen, I'm assuming? Okay. What? 5.9. 5.9. Sine of 22t. All right. That's it? I'm just teasing. All right. I had so much junk here, it's going to take me a minute to get rid of this stuff. Man. Okay, was there a y involved too? Yes. What'd you get? 8 cosine t. I'm sure you took a long time to like carefully plan this one, didn't you? No. Okay. Oh, you cheater. It's going back and forth and back and forth. I half expected that to keep going until I could like see a dolphin or something. So what is it doing? It's plotting points. You know, a TXY, it's just graphing a whole bunch of points. And what are those steps? Remember when we did the polar one, it was like how far it was moving each angle, each little angle. We'd go a step, one little step, and it would plot a new point, right? Well, this is making what move a little bit, and then it makes a new point? T. It's just making T move a little bit, and it makes a new point. All right. So there are all kinds of fascinating ones. Has anybody played with it and found one that was kind of cool? What'd you find? You can hit the on button to make it stop graphing. It'll break it. Okay. You guys don't have to type this in, but I'm going to type it in. 499 what? Tangent 1/2 cosine of t squared. All right, keep going. Why 499? Okay. All right, 499 what? Of sine t squared. Oh, thank you. All right, now I'm going to hit graph. And you have really made this thing work hard. In fact, I think you killed my calculator.
No, you didn't add a front jump.
I'm going to pause for a second while I figure this out. Awesome. All right, so here's another kid's creation. Now, how could I have made that go further? Like, I kind of like the pattern it was doing. What if I made it keep going? How could I do that? Yes. The T max. Good. So if I want to see what that would look like if it kind of finished the deal, I could go to my window, and my Tmax is 10 right now. Maybe I should make it like 30. And then try graphing that. So we're just simply playing and getting a feeling for what kind of things you can tweak. And you can tweak the steps. And, ooh, it's like it's making stars inside of itself. It's making an egg. And at the end, the egg hatches and unleashes a virus upon the world using the Bluetooth capabilities of your calculator. It's going to destroy the internet. All right. Thank you for that one. Yes, sir.
Can I do one more simple one?
Yeah, tell me.
8 sine.
8 sine.
4.5 t.
Wait a minute. I got to clear this whole thing. 8 sine 4.5 t. Okay.
And 2 cosine.
2 cosine 5 t.
And then you probably want to do that.
All right, I will do zoom 0, zoom fit, and so it's thinking about it right now. It's trying to think about it and graph it. Oh, there we go. Whoa, that is cool. Awesome. Okay. Now, do you think we could make that with a simple XY graph?
Yes. It wouldn't be simple, but anything.
And I love that attitude that anything is possible. Okay, how about this? Would it be a function?
No.
No. All right. So, seems like other people have got other cool ones that they've figured out, but we don't have any more time to play today, unfortunately. So, this is the part where we're going to do some review, and I just wanted to give you a chance to play with parametrics for a few minutes, and now it's time to go back to the basics of what a parametric is. All right. So, in the first place, it's got more data. That alone is something we're used to. You graphed those before, but you could only graph 2 things at a time, like height and time. But now when you include this extra thing, you can have more data. Like, for instance, I showed you how you could use this to figure out how far the ball is from you at any given time. And so you know where it is at a certain time in terms of X and Y, not just how high the ball was off the ground. You can know how high it was off the ground and how far away from you it was, and you can know the time. So anyway, they give you more info. They always have a little limiter over here that's like this. Why? Well, because you could go forever, but you don't have to, and usually these are limited. So here is a couple of problems that, if you understand what's going on, you should be able to do at this point. So I want you to work. These are tough enough that I did pair people up, and I'm going to have you try them with your partner. Can you take this, y equals x squared plus 3, and I want you to just make that, which is not parametric right now, into a parametric, and try to remember the little details. Don't just do this in 2 seconds because you can, and then you'll be wrong. Okay, think through what might you be missing if you just do a slap quick job. All right, I'm going to pause while you make that into parametric. Okay, you've had enough time that this should be done by now. Here's the main thing that people forget. I think most people remember that for parametrics you need an x and a y, and the y seems like it should just be x squared plus 3, but why can't it not be that? It has to have t. This has to be in terms of t. If you try to type it in the calculator, it won't even let you put an x in there. It forces you to put a t in there. When you hit the x button, it puts a t in. So anyway, obviously we can't have x's in there because x is up here, and x equals what? T. That's all you got to do. Now, That's a parametric that'll do the exact same thing, but it's got some piece missing. What would you get it marked wrong for at this point? You don't have any limits on t. Now, if you really want t to go forever, you could have said from negative infinity to positive infinity, but I don't want you to get used to doing that. I would strongly recommend that since you can pick anything for t that you want, that you should just pick t to between 0 and 1. And there's a reason for that it'll become more clear later. Okay? All right. Because, yeah, for right now, at least how many of you remember that you're supposed to have a t limit? Okay. And then you might not know what to do there, so put it in between 0 and 1. All right, next thing. I'm going to give you another one that you should be able to just slam dunk if you are on top of what you're supposed to be on top of. Here's an equation that is a parametric, and I want you to change it to be rectangular. Sometimes they actually just say non-parametric, which means rectangular. 3t plus 1 and 5t minus 4. That's an equation that's a parametric, but as long as I tell you this, t is between 1 and 3. Actually, negative 1 and 3. Sorry, make it negative 1 to 3. Just want to show you t's don't always have to be zeros or ones. They can go from the negatives. Now, I'm not asking you to graph this one. I'm asking you to change this to be not parametric anymore. All right, I'm going to pause for a second. I'll give that a try. Okay, again, if you really knew what you were doing, by now you would be done. Let me show you what you should have done. You should solve that for t, or the other one. Actually, solve either one for t. And I like to solve this one for t because then I can put it in here, and I'll have it already solved for y. You get why that's handy? Because what if the equation says, the problem says, and put y in terms of x? Then you have to have it solved for y. And so this is a smart way to go. Subtracting 1, I'll have x minus 1 equals 3t, divide by 3, divide by 3. T is equal to x minus 1 over 3. Then I put it here. So y equals 5 times x minus 1 over 3 minus 4. And some people will think they have to multiply it all the way out. They do not. At most, you will have to solve it for y. And it is solved for y. So I'm done. Some other kids are going to say, well, I solved this one for t, and then I set them equal. That's great. It's just that yours isn't solved for y then. You'll have two big fractions on each side of the equals, and it'll have only x's and y's, but just be aware you can be asked to solve for y. Now, what is tragically wrong with this? Kid would be so close, and yet I have to take off half the credit. Why? What is wrong? What? No, it's not the simplify thing. I just said you could leave it that way. It's solved for y. Yes? Yes, just like these have a range here. Not necessarily a range. It's a domain for t. But anyway, it's got a limit on the t. This would be a line that goes forever. Did this one go forever? No, this one only went between -1 and 3. And that might not be time. That might be temperature. T could be is some other thing, but it's only going from -1 to 3. So then how do I make this do that? Do I just say t is between -1 and 3? No, because then you'd be throwing a t into a x and y only situation. So this needs an x to be limited. The x needs to be between something and something. What and what? Seems like -1 and 3 would be logical if x was equal to t, but is x equal to t in this problem? No. I encourage you at this point to make a txy chart. Everybody make a txy, because that's what you'll need to be able to figure out what your limits on x are. Hint, do the endpoints. T equals -1 and t equals 3. I'll pause, we'll give that a try. Okay, you should have stuck in -1 for t and saw what you got. When you stick in -1 in here, You get negative 3 plus 1 makes negative 2. So x is negative 2. And y, when you stick a negative 1 in here, makes negative 9. Any mistakes found there, or did you guys get the same thing as I did? Okay, good. Then let's try putting in the other endpoint, 3. Granted, there's other points, but those are the two that t went between this and this. We got to see what that forces x to be between. Okay? So 3, when stuck in here, gives me 9 plus 1 is 10. And when the 3 is stuck in here, it's 15 minus 4, which would be 11. Did I get that right? Okay. Now, can you tell what the smallest and the biggest x will be? Negative 2 to 10. Does that make sense to you? Do you get why we have to limit it? Because otherwise that would be an equation that would go forever. It would be a line, if you graphed it, it would be a line that goes forever. And this one doesn't. This one only went between t is this and t is that. Yes? Okay, we did this as a little part of getting the answer, but the actual answer was this one. So that's just part of the process. Oh, I see what you're saying. So could you just have gotten your t's by doing this part? Well, let's see if we stick in a negative 1 here. Is that what you're saying? It's a good question. I don't know the answer to that. Did it work for you this time? Check and see if it works, and maybe it'll be one of those things that always works, but I can't promise that. Yes?
It works for me when I put negative 1.
So you're saying that it's just a simpler equation that you could have used than finding the TXY chart because you really don't need the Y's.
Yeah.
Is that what you're saying?
I just moved the x minus 1 over 3
Oh, okay. So you're saying since t equals this, you could put that in there. Cool. All right. Now, one of the reasons I brought up the TXY chart is because one of the skills, the next one we're doing, is where it's just plot points. Why am I saying that instead of graph it? Well, it pretty much means the same thing. It's just that you're not going to be actually able to graph every single point. So instead of saying graphing this, it would be graph a few points of, in other words, plot a few points on this. X equals Y equals, and I want you to, x equals 2t, and y equals t squared plus 1. I want you to do this between negative 1 and 3. I'll pause for a second while you just find, let me see, negative 3, or negative 1, 0, 1, 2, and 3. That's 5 points. Find 5 points that are on this graph. All right, so TXY chart. Dice of Destiny. Whose pose should I call on? Row 1, person 4. Mr. G. What'd you get for your first T that you put in? And you got? Raise your hand if you got negative 2, too. Okay, good. Now, if I know that you guys can all do these, I'm just going to ask you, Mr. G, to give me the rest of them so I can go faster. 0 gave you 0, 1, and 1 gave you, and 2 gave you. All right, and if I were to graph these, I'm not graphing them, but if I were, do you get the only thing I would graph would be the X and the Y's? But one more, oh, sorry, 3. What did 3 give you? 6 and 10, thank you. I'd only graph the X and the Y's, but when I do put a spot like negative 2, let's say it's there, I should label it with t equals negative 1. Just a quick reminder that these are directional, so knowing where it starts is a big deal. In the old days, you'd have a parabola, but your parabola didn't start here and end there. It was just a parabola that went forever in both directions. All right. And then 4, 5. 4 up 5. Thank you. I was wondering what the heck. Why was there an extra curve in that thing? All right, and then over 6 and up 10 is like way over here. So basically, it's a parabola. And you could have known that from this. Hint, what if x had been equal to t squared instead of y? Then it'd be a sideways parabola. That is correct. If y equals, that's what we're used to. That's a normal parabola. But if x equals, let's say, t squared, that's a parabola that goes sideways like this. Normally not possible because we'd have, well, first of all, if you go to the y equals screen, it's a y equals screen. It doesn't have an x equals option on it, right? We do now with parametrics. You got an x equals option. Okay, and one more topic. If this point 2 comma 5 was going to go to, why does the 2 matter? Because it has an implication of where it started and where it ends. If 2 comma 5 goes to 3 comma 10, my question is, if I didn't tell you anything else about it, you could write me a parametric for it, and you'd get to pick what the time was, and I told you already what a smart time to pick would be. Okay, so I'm going to pause for a second while you give that a try. All right, and I know from experience, and we have not that much time left, that a lot of people get stuck on these, so I'm going to get you started. X, Y. X started, would you agree this is the X stuff from 2 to 3?
Yeah.
And where did it start?
2.
At 2. And then did it go up? Yes, so you add, and how much did it go up? 1. And I need what in this equation? T. There you go. Use that same idea to do Y. It's the same exact concept. I'll pause while you finish that off. All right, so then I think you know that the Y started at 5, and then it went up. How much did it go up? 5. 5t. There we go. That's it. Now, let's say I think that I'm done. Always look for the limit. And in this case, the t is between, and I told you what you should pick. Even though it didn't say it started at time 0, it's still best to go 0 and 1. It's the least likely to screw you up. Okay, and then what if you wanted to check and see if you were right? Well, then go a TXY. I'm not saying you have to do this right now, but do you get if you made a TXY chart and it didn't have these points on it, you'd have a problem? All right. Okay, good. So what's new for today? Only one thing, and that goes like this. If you have y equals sine of x, why does that kind of make sense? Y goes with sine, right? And what does x usually go with? Okay, except what's wrong about this if I'm trying to make a parametric? I need a t, so let's make it t. And then t is not a time, for sure, because I'm doing cosine of it, right? So t needs to be what? Angles that can be in radians or degrees, but I'm gonna choose to do it in radians. So t has to be between, like, for instance, let's say between 0 and pi. Now, what are logical ones to pick? Well, 0 is a pretty easy one. Let's do the TXY chart on this, where we'll make t equals 0 as our angle. Remember, t isn't time, t is an angle. You're going to have to find cosine of 0, but hint, this is a point, 1 comma 0. That'll help you figure out the x and the y. What is the sine at this angle? And then here's pi over 2. That would be at 0, 1. And then here's pi. And it's at negative 1, 0. And I hate it that we're so pushed for time, but I have to just kind of push you through this. So do you get that we're doing cosine of t, which is cosine of 0. Cosine is the x, so it's 1. And the sine of it is 0. Do you get 1, 0 is my first point. Then the next one would be if I put in pi over 2. Pi over 2 is this one, and the x of it would be 0, and the y of it would be 1. And then lastly, pi. And if I do sine here, it's which one? Or actually, start with cosine. The cosine would be -1, and the sine would be 0. And now if I actually connect these, do you think it goes like that? Think about this. This is a trig. So what's it probably do? Makes a circle. So then here's the part that might kind of blow your mind. If I had let this thing keep going, it would have made a complete circle, right? So what's rectangular for it? This one's not just going to be a quick, like, swap this out for that. And what's rectangular? What's the rectangular equation for this if it had been a circle? This is one you're supposed to know for the ACT test, too. What's the equation of a circle in rectangular? X squared plus y squared equals the r. What's the r in this case? There it is. That's rectangular. You have to look at the graph to be able to see this one. That's the equation of a circle. How can I tell it's in rectangular? Because there's no t. Good. And last thing, these always need limits in this world. So, think about it. What were we doing? We were only doing the ones on the across the top here. Okay, so what was x between? So it's x squared plus y squared equals 1, and x was between -1. These are the x's. They were between -1 and 1. Yes, sir. It should be or equal to. Sorry, you're right. Okay. All right. So those are tougher to do just because you got to make this big connection like, oh, that equation in rectangular is one I know. You can't just process this and have it grind out to be, like the other ones, you just solve this for t. And this one you have to just know what a circle's equation is and be able to go, boop, I know that equation. Could they change the r on you? Mm-hmm. And would you be able to change the equation? What if the radius was 6? Well, and you just have to put a 6 here. 6 what? Squared. All right. Okay, so that's the only thing new for today. Now, your homework. I assigned day 1 and day 2, but day 2 I cut you off before you got to the really challenging word problems. Instead of doing really challenging word problems, I feel it would be better for you is to go back and do the ones we skipped over in there, which had trig in them. So I'll show you where those are. Pause while I get. So here we are in the day 1 assignment, the problems we skipped a couple days ago. Okay, so you're doing now the ones you skipped. You're doing problem 10. And notice it says convert to non-parametric form. Ooh, that's what we just talked about. So you have to graph this thing, make it TXY chart. You'll figure out, ooh, maybe this thing's a circle except it's got a bigger radius. Okay? So I'd always make a TXY. Once you're done with finding a few points, hopefully you'll make the connection that it's a circle. And then hopefully you'll make the connection between what the regular form for a circle is in rectangular form. All right, and then these two questions, it does specifically say with the help of a graphing utility, so you can absolutely use your calculator to help you. Then you can't just take a picture of your calculator and slap it on there. You do have to actually make the graph, but your calculator can show you where the points are. And don't forget that there's a table button if that's necessary to help you. Okay, so really the only extension today is the whole trig thing, and the main thing with the trig thing is that you know the equation for a circle in rectangular. And what is it again? X squared plus y squared equals r squared. And usually the radius is 1, but it isn't always 1. And then last thing on that, you also have to limit your x's. Just like we just always want to have a limit. In parametric, it's always t is between this and this. In your rectangular, it's always x is between this and this. Okay, so don't forget and just write an equation. You got to have an equation with a domain for x. And just look at your graph. Usually you can tell what x is between. Okay, that's the last day of new stuff. Tomorrow's review. Friday's the test. That's all I got for you for today.